Hey friends, how's everybody doing today? Happy Tuesday. Alright, this one's done here in just a second. Got a couple things on tap today. We'll talk about Project 3, then we'll talk a little bit about exceptions and advanced file I/O, enough to get you started on Project 4, and we'll talk about Project 4. We'll come back next week to finish off exceptions and advanced file I/O, and we'll do a little bit of midterm prep as well. There we go. Oh, that one just got quiet quick. There it goes. So I'll give you last semester's midterm if you want to review that tonight, and then next week I'll plan on going over the solutions to it, because if I just show it to you and then solve all the problems, it's not very interesting. It's not a lot of practice there. So we'll talk about it. It'll be a timed exam here on D2L. I'm going to open it up on 7/13 at midnight in the morning, in case you're a morning person. And it'll be open all day long. You'll have up until 11:59 p.m. on 7/13 to hit the start button. Once you click start, you'll have 4 hours to finish it. So it is a timed exam, so everybody gets the same 4 hours to do it, whether or not you're a morning person, an afternoon person, or an evening person, whenever you have that 4-hour block of time. The goal is that it takes you, about 2 hours or so, but it should not be the whole time, but I want to make sure you have enough time here, because I know trying to write even little code snippets under time pressure is really annoying. So we'll have about 15 quiz style questions, those short answer, fill in the blank, multiple choice, not multiple choice, true, false, correct the statement, short answer style, which reminds me, I forgot to post the quiz for chapter 10, so I'll get that posted for you tonight. And make myself a note there. And quiz. All right, I'll get that posted for you folks, and it'll cover everything up through exceptions and advanced file I/O. So it'll have, again, 15 quiz style questions at 1 point each, and then 3 long answer questions that are like, hey, write a piece of code that does this. So we'll do one about just classes and objects, we'll do one about inheritance, and probably do one about advanced file I/O. Okay? So let me grab that here. Add a new section. So for midterm review, it is open book, open notes. So 12 a.m. on 7/13. Started anytime. 11:59 p.m. No, Starborn. I'm just broken. It's been a rough June, worse than I thought it'd be. So my apologies. I'll make sure I've got everything in for you. Should be all the quizzes for sure, and at least the first or second assignment by next week. I'll make sure I have that all wrapped up for you guys for if you want to review any of that for the midterm. Start. So it is open book, open notes, open internet, but not open neighbor, right? You may not work with anybody else, or Chegg. Right? Chegg is terrible. I hope they go out of business because they get sued by somebody. They're just awful people. Please don't post stuff on Chegg. Right? That's just an immediate violation of our academic conduct policy. Instance of academic misconduct. I have to remember what we call it here. Okay, so it'll have 15 quiz style short questions at 1 point each, 3 long answer questions at 5 points each. Okay, and let me get you grab this here on the other screen real fast. We'll go grab last semester's. Where'd it go? There it is. All right. There we go. All right, and the print to PDF is awful here, so let me grab this here. Again, it's 19. The first question is actually you agree to the academic integrity policy. So it's actually 31 points, but that first one's a freebie. All right, save that as a PDF. This is 151 midterm review. All right, awesome. And then we'll pop that in here. Okay. And we'll take a quick look. So again, you just understand the academic integrity policy for the course. You may not work with other people, and I'll include you may not post up on Chegg because I really assumed that was obvious previously. Apparently I need to be more explicit. Right, so everything you give me is assumed to be your original work unless cited otherwise. Right, and then a bunch of true-false style questions, short answer style questions like you might have been familiar with from the couple quizzes we've had. Again, I'm sorry I missed 10. I'll post that one there for you in a little bit. And then some long answer questions. So this one here. You're going to write a class Sunday. It has an array list of type string to store the ingredients, integer value for number of scoops, a double for cost per scoop, and a double for price per extra ingredient. You'll have a method add ingredient that accepts a string value and adds it to the array list of ingredients. A method get total cost returns the cost per scoop times the number of scoops plus cost per ingredient times number of ingredients. Write a unit test for get total cost. So the class plus a unit test for get total cost here for that one. Write a function cipher that takes a string word that accepts that takes each character in the string. If it's an even index position, add 1 to the character value. If it's an it's an index odd position, so if it's at an odd index position, that's a little worded funny, sorry. Subtract 1 for the character value. So if I pass in AAA, I'd get back B at B. That's the cipher. And then write a class that extends stuffed animal as linked here. When making a noise, if battery has power is true, return the string that includes the name and the appropriate animal noise. Otherwise, return an empty string. Generate a random number between 1 and 10 after making a noise. If you get a 1, set has battery power to false. So I think that link, I'm logged in here. Let me try it in a browser I'm not logged in as. I think that one's still there. Or maybe I took this repo offline. I took it offline. Okay, I'll post that one here for you. That one's not too big here, so I'll add that up here. Yep, that ought to do it. Okay, so there's the stuffed animal. And so this is the class. It's an abstract class. You need to extend it. It has a constructor. It's got an attribute for name, methods. Okay, and I think that was the last long answer one there. Well, this similar style question, relatively short here. So again, our questions then, we're going to have one from chapter 8. Let me edit this here. Answer one from chapter 8. 1 from chapter 10, and 1 from chapter 11, right? That's what 11's our chapter tonight, right? Yeah, 11. So 8, second look at classes and objects, 1 from 10, inheritance, and 1 from 11. But we're going to skip the text processing and wrapper classes. We don't need a long answer question about that. Okay. Any thoughts, questions, concerns on this one? Again, we'll spend a little bit of time next week. I'll go over some of those answers. So you'll want to try it yourself first, right? And if you get stuck on anything, let me know. If not, we'll talk about it next week. That sound good? All right, so we're going to talk about Project 3 tonight. Let me fire up NetBeans here. And I think we had some starter code here that we talked about, right, for our little Animal Craft game. Close out these projects. All right, and we'll go find that little starter code we had. 51 for the summer. So little project 3. Little starter bit here. All right. Cool. All right, so how'd this one go? This was a little more open-ended. Just trying to get you to play around with some of these tools, use some inheritance, implement some interfaces, and then see if we can make classes talk to each other. Again, we didn't have to write the actual game portion to play it here, just to write the classes that enable these different features here. So that we had the player class was 5 points. So the player class should have the name, the island, the list of friends, list of tools they've picked up. The island class is that 2D grid of spaces. We were generating a random one here in island of just regular spaces, but we need to have the actual like implemented spaces here for other ones, like if you have a diggable space or a buildable space, or what was that other one we had? Choppable, right? You maybe had a tree in the space there, so we can have a couple different subtypes here, or child types of space that we could include in our random island. And then some spaces then would have a tool on it as well. So if you were buildable, diggable, or choppable, you probably didn't have a tool, So, and then that was our interface class. The interfaces with method names, we're going to have interfaces for like is buildable, is diggable, is choppable. The space class, spaces have random tools or implement interfaces. That was the subclassing here, like diggable space or a random chance to have a tool. The tool allows the player to use the matching tool on a space with the matching interface. So if we have a tool like an axe, and we're on a space that is choppable, we should be able to cut down the tree. The friend functionality, visiting versus editing someone's island. So if you were listed as a friend for them, then you can edit their island. Otherwise, you're just visiting their island and you can't actually do anything like chop or dig or build on their spaces. Okay? We're just trying to write some of these classes here, see if we can get them to interact a little bit. So we had player, and then player was supposed to have an island, right? So you would have your home island here. You'd have a private island home or something, right? We can call it that, sure. And then a private array list of... Now, we could go with classes for tools if we wanted, right? Or we could just be cheesy and have a bunch of strings and do matching strings, right? Our tool maybe has a name. You can get the name of the tool. So if you want to do something more interesting with tools down the road and like have them break or have them have some sort of durability and they'll wear out at some point, we'd probably want a class for it. But if you just pick up an axe and then you have that axe forever, then great. Right? Then you can always chop things forever. So we can go either route. We might as well make a tool class. Doesn't need to be too hard here. So we're in a class for tool. Right? And then tool will have probably a name, right? Private string for name. And again, we don't really have anything else happening here, so we'll just enter some code, have an autogen, a constructor, and a set and get method. Get and a set. Cool, we can do that. So we want an array list of type tool here then. We'll have tools. So then the constructor for player, right, needs to do a couple things. So player probably has a name as well, right? String name. String name. So maybe you need to give it a string for the name when you make a player, right? And then this name is the name. Sure. And then home equals a new island. I'll generate a new random island, or if you wanted to do some other option, we could do that, right? And then tools will be a new array list. It's empty to start, right? We don't have any tools. So then can dig, we need to see if we have a tool that can dig. Right, so we need to check our tools list to see if we have one of a given name. So again, we're probably still doing this off of name. Or we could even do subclasses is probably wrong here, but we can just go by name. Right? So we can say for tool in tools, if tool.getName, parentheses there, tool.getName equals ignore case. Yeah, ignore case. If it equals shovel, we can dig. Return true. If we haven't found it, we've looped through all the tools, will return false. Right, same idea for like chop or build. So can chop. Look through our tools, find the one that lets us chop. What's that? An axe. Right, and then how about a build? Can build. How about we find one called a hammer? Right, just kind of build out a couple methods here for being able to figure out whether or not we can do these operations here. Okay, we need to add our import for array lists. It's happy there. Okay, so island we still need to fix, right? So we've got a diggable space, we need a buildable space, we need a choppable space, right? So we might also want to check, like, if there's already a hole dug, you probably can't dig. Right? Or maybe we can also check the descriptions. I don't know. And then maybe this diggable space then is what a space have. So space either takes a description or not. So why don't we make a constructor here, diggable space, and then we'll just call the superclass and we'll give it is an empty space with sand pit in the middle or something. Right, you can dig in the sand, I don't know, or dig in the dirt, whatever you want to call it. Give it some kind of description here. And then you dug a hole in this space. Sure. Or a place to dig. How about that? Place to dig. Keep it even easier. It's an empty space with a place to dig. Okay, so we'll make some other classes here. We'll make a choppable space. That needs to implement is choppable. We'll have an is choppable. Is that 2 P's? I don't know if that makes, no, probably just one, right? Choppable. I don't know. 2 P's, 1 P. I'm gonna go with one. Because one sounds better. And this is chop. So our choppable space. Let's rename that one. Refactor, rename. Like this. 1P there. Choppable. And this will implement the is choppable. And it's going to tell us no, it doesn't. And so we'll say, okay, let's implement the method. Then we can paste in our stuff here. You know what? It's not even too bad. That's fine. Oops, too much. There we go. So our choppable space, an empty space with a, or this space has a tree. It's a tree, and then when we chop it, we want to make sure that they can chop first. So if the player can chop, we'll go do something. So if player dot can chop, say you cut down tree in this space. Okay. And if they can't, then false. We just nothing happens. Oh, extends space. There we go. Now it likes our superclass call. If we are a space. And then we need a buildable space, right? So we'll have an is buildable interface with the build method. Okay, so let's make another space. This is a buildable space. Extend space implements is buildable with a build call. And if player can build, empty space with a place to build, sure. You build a fort, I don't know. Built a fort here. Sure, some kind of description there. Okay, and then we need to have some, we just have a generic tool here, right? We're going to have some tool names. So maybe we might want to have then a list. How about that, right? What if we had a public static constant string what axe is axe, and a public static constant string for hammer. Oops. Final string hammer, and a public static final string for axe, hammer, dig, shovel, right? Shovel? Or maybe those are all lowercase. I don't know. Probably doesn't matter much. Okay, and then in here, then we can actually be a little bit better. And if our tool equals ignore case, tool dot shovel, right? Or tool dot axe, right? Use those nice little constants here. Tool dot hammer. Okay. Cool, I like that. So then we have our tools, we have our spaces here, we need the island then to generate random spaces or random tools. Sure. So instead of it just being a space here, we got to figure out something random. Okay. So let's build a random. Let's use random here. So we'll have random. We can just do it right inside the constructor probably, right? Oh yeah, we got a random already. Look at that. Perfect. So we'll say, oh, maybe we could use a switch, but if else's are probably just as good here. So we'll say int random number, random dot next int, and we have 3 different tools, we have 3 different spaces, plus just a blank, so maybe 7 different ones, or maybe we want more blanks than others. And then, you know, if random number is less than 4, so 0, 1, 2, and 3, right? 4 chances for just a regular space. We'll have a space, new space. New space is equal to, just, I don't know, let's call it an empty space, so we probably don't need a number here, right? Okay, else if my random number is equal to 5, I'm sorry, equal to 4, right? Then my new space can be a diggable space, or buildable space, right? Why not? And that doesn't need anything for the constructor, right? They're all just buildable. Else if we're a 5, we can be a choppable space. Else if we're a 6, we can be a diggable space. Else if we are 7, we need a way to add a tool to a space here, right? So space doesn't have a tool. We can have a private tool. Now, space could either randomly generate tools, or we could assign it here. So maybe we want a set and get for tool. Right, so maybe we'll add some code for sets and gets for tool. That way you can add the tool, right? So we'll add a getter for tool and a setter for tool. insert code, set tool. Okay, and we'll call it set tool just to null if we don't have one. Same here. Well, I guess we just do it. We just do it in the other one, right? Because we're already calling our other constructor. We'll set tool to null. Sure. So if you don't give me a tool, it's not there. Right, so you gotta be a little careful here because you might get null back. Or maybe we could even like add a method like has tool. Boolean has tool, and then we'll return tool does not equal null. Right, just to give them a quick little, hey, you can see if you have one or not. Sure, why not? So most of the choppable, buildable, diggable won't have tools. That's fine, no big deal there. But then we can add some tools here for our other new spaces. So if it's a, oh, I already did a copy paste. So if this is a 7, then we want a new space. Oops, copy that. Still an empty space maybe, and then maybe we'll say new space dot set tool, given a new tool called tool.hammer. Sure. And the tool needs a name in it. Sure, why not? So it could be an axe, a hammer, or a shovel. That's fine. Or this one could be random too. It's probably nice to be able to specify it though, so not everything's random. All right, so that's a 7. We'll have an 8 and a 9. So an 8 and a 9. Tool.axe and tool. My goodness. Hammer, axe, and shovel. Okay. Then, when we're done, now the grid.getRow.add, we can add the new space. So it's either, because remember, index next 10 is going to be 0 through 9, so I'll have 10 different options here. So the first 4 will be empty. 4, 5, 6, 7. I'm sorry, 4, 5, and 6 will be buildable, choppable, or diggable. 7, 8, or 9 we'll have one of the tools. I mean, we could tweak this. We could do all sorts of ranges depending on how we want to kind of distribute this randomly here. But we've got a chance of it being any of them. Okay? So getting the description here, sure, right? So we should be able to figure out what our description is. So maybe this says, you know, space, how about that, with a hammer. But this one says space with an axe. Space with a shovel. And then let's see, right, when we're done here, what's it upset about here? It's upset it might not have been initialized. So hey, you know what? Let's just do this. We'll leave it as this one here, just to make that error go away. We'll say it's an empty space here, and maybe these ones are, I don't know. Sure, that's fine. Or this could just be an else. Right? We got a couple options here for how we want to handle that. Maybe that's the default case. I like that. So we'll just do. Wait to start at 4. So 4, 5, 6, 7, 8, or 9 gets one of those. If it's not one of those, we just have the empty space. Why is it upset with that? Yeah, we can replace it with a switch. That's fine. We don't want to do that. Somebody doesn't like switches. You folks still there? Hanging in there? We doing all right? So we should see if we can actually print this out then. Right? So we're able to make an island and print one. See what happens. Should get a bunch of different spaces. Right, space with a shovel, empty space with a place to dig, place to dig, place to build, space with an axe, space with a hammer, space as a tree, place to build, hammer, shovel. Looks like we got all of them here, right? Just as a quick little eyeball. Right? Okay, how we doing? So we've got interfaces with method names. Our island class is basically the 2D grid of spaces. The player class, right? Name, island, a list of friends, other instances of player. So we don't have the friends yet, and a list of tools picked up. So if player needs to have a bunch of friends, then we'll have a private array list of type player we'll call friends. Right, and then our constructor then should set that to be a new array list. And then we need a way to add a friend. So public void add friend, given a player we'll call friend. We'll take friends.add the friend. Right? Cool. And then, I don't know, how about a boolean is friend of, given a player friend? Now, the equals method is going to be a little tricky here, because remember, equals will only work if it's the exact same memory address. So we might be better off just checking name, if the name matches, which is not ideal, but that's probably okay. So we'll add some methods here then, right? We want to add some code for a get name, get your island home maybe, get a list of friends, get tools. Yeah, we can do all those. Why not? You gotta be a little careful when you're returning array lists. Remember, those are reference types. So if you give someone your list, they'll be able to modify it here. So just, you want to be careful. Right, so just, I don't know, a little warning here. It might not be good. Maybe we want to make a copy instead. We can decide that later. But we can get their name out. So if someone is a friend then, so is friend of a given player. So we're going to say for player friend in friends, if, oops, can't use that, current friend. So for current friend, is that friend? I can't even spell. Is that right? It looks wrong. I've written it too many times now. Friends? Friends. That's right. Friends. Fry end. Okay. I don't know why that looks so weird. So if the current friend dot get name dot equals, ignore case, the friend dot get name. Because of course you're never going to have two Erics as your friends. You know, growing up in the 90s, that obviously never happened to be in all of my classes ever. I think one time there was not another Eric in one of my classes. There were 3 in my elementary school class, and then in the entire grade, I think there were probably 5 of us Erics. So, but sure, you know, we could do better, but this is enough for now, right? This will be okay for now. We'll return true if we found somebody with that name. So you must be friends with them. You're friends with an Eric. Sure, all Erics are the same. If not, we'll return false. We don't want to use equals because I might not be the same memory address, right? I might be a copy of it. I might have 2 friends with the exact same attributes, but then they might not be equal. And we haven't talked about how to compare objects that way yet, and we probably won't get to that until data structures in 2353, where we talk about equals. Or did we talk about equals? We did comparable. I mean, comparable would probably be the same thing, like, is the name the same? And so, yeah. Yeah, and we could override the equals method, but this is probably fine for now. Because we don't know if friend, I guess we could write friend to do that, but that's harder than we need to do right now. All right, so we can see if we're a friend. Great. If we're a friend of that player, true. If not, false. Okay? And then island needs to know what players are on it. Right? So it's going to have an array list of type player. This is players. So it should start off as empty, right? Players equals new array list. Starts off empty, and then we need a way to add players. So we'll have a void add player, given a player. Players.add player. And maybe a remove, right? Like once you leave the island, remove player. Player. Maybe this is a boolean, right? Because I think the array list does that for us, right? So player.remove, no, players.remove. Remove the player. Does remove return? Doesn't it? Does it not say? Let's go just Google it. Java API array list remove. Remove. Let's see. Remove. Oh, we'll remove the object, but yeah, we'll give you back a Boolean. So whether or not we remove this, we can just return the result of removing that player. And again, this is my memory address, so maybe it's not ideal, but if they're on my island, I probably have them in memory. Maybe that's a bad assumption. But yeah, I guess maybe we wanted to add an equals to player. We do that. Did we do that in project 2? I feel like we did that. Let's see. Do we do equals? Equals? We didn't do one, did we? Okay. That's fine. The equals method is not too bad to override, but it's a little funny. We can do it. So we're going to override the Boolean equals. Now the problem with equals is that it has to be an object, right? Because otherwise we're not overriding it. It wants us to use the hash code. That's fine. We should be fine with that. So first we want to see if other.getClass equals getClass, right? Or really, if it does not equal getClass, we're going to return false, right? If we're not the same class, then we obviously can't be equals. If we are the same class, then this is my other player. So player, other player equals, we can cast other as a player. Then we can return other player dot get name dot equals ignore case get name. And we're just going to compare names to see, hey, do we have the same name? And sure. I'm not too worried about it. There's probably better things we could do here, but that's okay. Okay, so if we're not the same class, no, get out of here. Can't be equals. Because we have to compare ourselves with an object. Otherwise, we're not overriding. If we said, hey, player other, then we're not overriding. Right? It makes this a lot easier. We can just return that right off the bat. But then we're not an override. Not the worst thing in the world to not override it, but it's fine to override. Okay, so then we can fix that up then. So if we're friends, then now this makes it a whole lot easier actually. So now we can just return friends.contains friend. Remember, array lists have this cool contains method. We can see, hey, do you have this value? And contains is going to use the equals method to see if it's in there. So that simplifies that. You know what, I should leave that. Let's copy that and then undo all that other stuff. We'll leave all that there, but comment it out. Right, so once we have equals, we don't need to do this the hard way. You with me so far, folks? Let me know if I'm jumping over things or if it's not making sense. We're just kind of, again, going at it piece by piece by piece, seeing if we can start tackling some of these things. Our player class, our island class, our interfaces, our space class, our tools. Right? So if we have the right tool, we're on a space with a matching interface, we can use the tool. Cool, and our friends functionality, so we can check if we're a friend of somebody. Right, so maybe then island even has like an owner. We could do that. So we need to be able to get a space out, right, for a given location. So public space, get space at row index and column index. Return spaces, no, grid, sorry. Grid.get the row index, .get the column index. Right, so get row index will give me back the second dimension. That will give me the other array list of spaces here, which I can then get the column index out. So I get a given space at a location here. And they'll be able to go and modify it, that sort of thing here. So space isn't going to know whether or not we can change it, right? We'll just have whether or not we have tools. So we'll need a way to know if they're allowed to dig at a space or not. So maybe we'll add a Boolean. So we'll say, I don't know, we'll do a little wrapper here. So public Boolean can dig space at a row index and column index. So if the grid.get right, so that's a space, and then we want to get what all of its interfaces, right, to see if we are able to dig at it here, because right now it's just a space. So we need to treat it, right, to see get all the interfaces that it implements. And we did this. Where was that? Our implements something. We had that loop there, right? Here, let's just go back. Look at last commits. There we go. Is assignable from. There we go. That's what I was looking for. So if is diggable dot is assignable from, or no, dot class dot is assignable from the grid dot get row index dot get column index dot get class, right? Then the space is diggable, and we also have to be on the friends list, right? So we probably need a player which is the owner of the island. So when you make the island, you probably need a player who's the owner. We'll set this dot owner to be the owner. So you can either be, right, so if it's assignable from that, right? And then oh, well, we need to know, well, who's trying to dig it then? So a row index, a column index, and a player. If player dot equals the owner, or friends dot contains the player. And really, we can just return that. We don't even need an if. We can just return that whole big ugly thing. Somewhere too many curly braces. Friends, right? Isn't it? Oh, owner dot friends. That's right. So owner dot get friends dot contains. So either it is the owner or you're in the owner's friends list. That's what it is. So then you can dig that space. And can chop space? Sure, why not? Can we chop the space? So is choppable, is assignable from that class, and you're the owner or a friend of the owner. How about can build space? So is buildable, and you're the owner or the friend of the owner. So we can get the space back out, and then we can say, hey, can we build here? Can we dig here? Can we chop here? I don't know, pick up the tool from or something. We got lots of different options here. Right, so the idea is we want island is kind of going to be where we're working with here. So island has the bunch of spaces, and we'll ask island to do things for a given location because we need some place to start managing all these things. And if we have to track, hey, this is the space that you're on, we could do that maybe. You know, or maybe the game does that for us. Maybe we'll have another thing that tracks where the players are. Let's see. So what is it said about player now? Oh, that's right. So we need the island. The owner is this, right? Because we are the owner of the island. That's our island. Okay, and then project 3, new island. Oh, so we need a player then. So player equals new player. And then player will automatically make the island for us. Player needs a name here, right? So this is Eric's island, or Eric. Right, that's my player name. It'll make an island for me. So player.get island. Oh, we can't get the island. So does player need a get island? Oh, we have it. Oh, it's called get home. Sure, get home. Dot get home. And then we can print, we'll print out the player.getHome. We should still get an island out, right, with a bunch of random spaces. Now, I don't know where I am on the island yet, so I probably need to know where I am. Right, and we could track that. Maybe island knows where all the players are, or player could have a location on the current island. I like that. So player probably has a location. So private, I don't know, init array maybe. I almost always prefer array lists, but this is so easy. Like this is location XY or something. And then my location XY can equal a new int array. And we'll just start it off at, say, 0, 0. So for now we're at 0, 0. And then we need a get and set location. So we'll insert gets and sets. Set location is probably fine, right? We can say, okay, here's a new XY where you are. Sure, we'll probably do something like that. If we can dig, if we can chop, if we can build. Right, I guess, so island probably also then can check if the player can do that too. So if they can dig the space because you know the player, right? If it's assignable from, and they're on the friends list, right? And the player can even dig. So we can just add player.candig and this one. Right, player.canchop. And so does the player have the space? The player who's trying to do this thing can build. Yeah, we can add that in. So a little format here. Okay, so if the player who's attempting to dig can dig, and there's a diggable space, and they're the owner or the friend of the owner. It's kind of and or all those together in there. So we get the space out, we can add players, we can remove players from our player list here. Players have their own XY. Sure. So maybe somewhere in that game loop, right, when we try and go up, we go down, we go left, we go right, you can get some different spaces out, right? So we can get spaces at given rows and columns, we can move to that location, and then we can update our location in player. This making sense? I think we've got lots of different activity here, but I think some ways we can interact with it for sure. What do you think? Do we have all of our visiting versus editing? So you can move around, but you can't do any of those actions. Oh, how about like pickup tool? I guess we should probably add that pickup tool for a given location, right? So a public, I don't know, Boolean pickup. That should return a tool, right? Tool, pickup tool from an int row index, column index for a given player. You know, if player has an X and Y, we probably don't even need the index is here. Look at that. We can clear those out. So we just need player.get location XY, and the row is the X, right? So that's the first one here. And the second value is the Y. That's a little bit ugly to do it like that, but I'm not too sad about doing something like that. We'll just ask the player for their X and Y. Right? So if we know the player knows where they are, we'll just ask the player. Okay, so then we're going to get the tool from that space. Right, so my grid dot get from player X, get player Y. So we'll have a tool. Tool is the grid, right? Dot get tool. So we'll ask the space to get the tool. That may or may not be null here. So sure, that's fine. So once we pick up the tool, I'm not liking this. Let's do this. We'll do space. I don't have to do that twice. Space.get tool. Okay, and then once we pick it up, then space.set tool to null. We picked up the tool, right? It's gone, and then space.set description. Or maybe if it already had one. Oh, that's right. We had a has tool, right? So if space.has tool, right? Then we can go pick it up, set the tool, and then set the description. Space.set description to empty space, and then we'll return the tool. So we need to define it here. Start it off as null. We can pick it up here, and then we just return. So you might return null when you go pick up a tool if there's no tool there. So, right, we'll get the space that they're on. We'll assume it's null. If there is a tool, we'll get it, set the tool to null. We took the tool off the space, set it empty, and then we can return the tool. And probably if we have a tool, then and we're a friend, right? Because you shouldn't be able to take things from someone else's island if you're not a friend. So if you try to and you're not a friend or you're not the owner, you'll just get back null. Nothing happened. You didn't pick anything up. Right, so you see we're kind of interacting with, so Island is giving us all these options here. We're saying, hey, here's the player, here's what they want to do. And then Island is going to interact with its spaces here to figure out the results of what's happening. So maybe instead of can dig, maybe we actually dig the space then. Right? Should we dig instead of can dig? Or we can do a mix of that, right? You could have a can dig and a dig space, right? Or they can just call their own dig, right? Because we can get the space out. We were giving them get a space, and then the space has the can chop here. Well, that doesn't do the friends check though. That's a bummer. Yeah, we probably want it to go through the island, because then the island knows which the player is and what their friends are. We don't know whose island this space is on. Or spaces could know what island they're on, I guess. I think we're pretty close. What do you think? So again, all we can do really, like we can make one, we have no way to really interact with it. We'd have to add some sort of loop, like, hey, do you want to go to an island? Do you want to go to your home? Right, because the player can get the home. And we'll set them to a home here. Right? Or we can put them on another island. Then we can add that player to a different island's player list. Right? So if we have another player, we can get their island. Right? Because player has a get island. Do you have a get island? Oh, get home, right? We have a get home. We can get the other player's get home and then take their home and add us to it. We can go visit their island and play with it there. What do you think? Was this similar to what you folks had? Am I way off base? Did you go a lot farther? Not as far? I don't know. The get location XY is a little bit ugly. I'm not liking that. Should those just be separate? X and Y? We could do separate X and Ys, but I feel like it might be better to do separate X, Ys. we'll do that. We'll just do a single location X. Location Y is 0. Get location X, set location X. And then same with Y's. Okay. So we have separate X and Y's. Location Y. All right, so then that is, you got to fix these ones here. Get X. Get Y. Get X, get Y. Just get X and get Y. That's a little easier. I like that, instead of having to get it the array. This feels better. You folks are a quiet batch tonight. Was this a lot? Too much? Confusing? I know it was really open-ended. That's kind of the idea, to let you have a chance to try and play with these and see, can we figure out how to make these go, kind of interact with each other. There we go. I think I lost you folks. Okay. Oh, there you are, Professor Burp. Thanks. Good to hear. Yeah. It says only 9 people are on tonight. Oof. Out of the... What do we have left in the class? We got a bunch left in the class, don't we? You know, a couple people had dropped, but I don't think most people had. Let's see. Let me check real quick. Ooh, we're down to 20. I think we had a little more than 20 when we started. Well, I'm supposed to tell you too. Good news. Good news. Our schedule is out for next semester. The summer semester schedule is out and posted on online services here. So if you're looking at classes come fall, you can see what's available. Registration starts in, is it 2 weeks or so? It's listed somewhere up here, but you can see what classes we have coming up. Pretty excited. If you haven't taken 2454 yet, I'll be doing that one. If not, you probably won't see me again, because I'm only doing that one and 1500. Still got a lot going on, so try not to spread myself too thin. I'm hoping to get back into my doctoral program come fall. Okay. Yeah, unfortunately, most of the courses, at least in the software engineering program, are in person. We don't have very many online. There were a couple earlier in the program, like 1200, 1300, systems analysis. I think that's our only 200 level course that's offered online. Yeah, systems analysis and design. This one will be online asynchronous with Dr. Othman. He's fantastic. This one is a hybrid. Take place via Zoom. So that's online synchronous or something? It looks like an online course, but it's not listed as online. It's listed in a room. That's interesting. I don't know what that's all about, but Dr. Othman's teaching this one fully online, asynchronously here. And if you do need to take 2454, I'll be doing the same sort of thing where I'm broadcasting on Twitch, but I'll just be doing it from the classroom, trying to do a little bit of a flex format. For anyone who wants to come in person, I'll be there in person. For anyone who wants to be remote synchronous, I'll be here on Twitch. And for anyone who wants to be asynchronous, they can just watch the recordings. And I'm hoping that format works well. I'm going to try that with my classes in the fall once we're back in person, and we'll see how well that goes. Okay, so schedule's out there. Don't forget, you can take a peek what classes are there. Yeah, cool. All right, let me commit this to GitHub here. Again, you could have just had a string for tools, a string for names for your friends. We got lots of different options there. And it's not just one right way to do things. I think this will set us up for success later, but we'll see. We'll find out. All right, so this is project 3. All right. Awesome. So we start up a new project here. We're going to talk about exceptions and advanced file I/O. Exceptions and file I/O. I/O for input output. Again, we'll make sure it's in the right repo. 2151. So finally, we get to talk about exceptions. Exceptions are the things that crash our program. Right? Remember when you get all those red lines and your program crashes and you see that ugly stack trace? That's an exception. Right? And lots of things can cause exceptions. In particular, file input and output operations can cause lots of exceptions. If you try and open a file that's not there, if you try and write to a file you don't have access to, all sorts of other things can kind of happen there that are exceptional. Something that should, probably what you didn't expect to have happen, and will crash your program. And nothing seems to frustrate people more than having programs crash, right? I don't know why, but like, it just puts me in a bad mood if something crashes, because I feel like they could have done better. Maybe that's just because I know how these sort of things work, and it probably shouldn't have crashed if you tried a little harder. That's all. So with exceptions, we can handle them so that we don't crash. We'll get to that part a little bit later, probably next week actually, but we'll just know when we're dealing with file input and output, exceptions happen. So remember when we did basic file input and output, we used this print writer thing. Print writer, this should have been from 1500, like a file or output file or something. Output file is a new print writer. And you just give it the name of a file here. Print writer, test file, and if you give it .txt, great. Windows or Mac or Linux will know that it's a text file. It can open it up nicely. If you don't give it an extension, it's still a text file, but your operating system probably doesn't know that, and you just have to tell it actually is. So we add our imports, and it's still mad at us, and it says, hey, we have to add a throws clause for java.io.file.found exception, or we can do a try-catch block. So what we're going to learn later is what this try-catch block does. So this logger's ugly. We don't want that. So we don't need the loggers here. But try says, hey, I'm going to do something that might throw an exception. And then catch, if that exception happens, what do we want to do? And for now, we can just print the exception. Again, there's other better things we can do. We'll get more to that next week. But for now, we're going to try this thing. And if it crashes on us, don't crash. Please give the exception, and we'll just print it out for now. Okay? And then we'll take our output file, and we're going to print line, I don't know, 1, 2, 3. 1, 2, 3. And then when we're done, we close it, right? So anytime you're working in files, you open it, you read write it, or you close it. Always those three. And again, you can do this cool try with resources. We'll look at that later, okay? That'll be for next week. Or for now, we'll just follow our same operations here. And then NetBeans is really handy here. You got this little file viewer. So usually we're in the project view, but you can go over to files and open up your project. And then in there, you should see your file if it was created. Oh, goodness. Did it not go? I didn't get a test file. Of course I didn't get a test file. Run. Nope. Friends. Where's my file? Sure. It's not even in GitHub. What? All right, now I'm confused. That should have just worked. Where? It's not in here. The file? In the print writer? Close it. Okay, so it's not running anything. Oh, geez. I haven't had this happen in a while. So occasionally, it seemed like it wasn't a problem. I just recently had to upgrade NetBeans for my other class. You go to Properties and you go to compiling. This compile on save doesn't work for some reason for me. You're supposed to need the plugin, and I have the plugin, but apparently I didn't actually get it. So now when I run it, now it actually does a bunch of stuff. So I don't know. That was really weird. Now I get my hello, and now I should have my file here. There we go. Test file.txt. I'm much happier now. Test file 123. Okay? So you can make text files. They're really boring. Right? They're great, though, but it's text. And the problem is, remember, everything that is text is stored as an ASCII character. There's actually this really cool Unicode format that's used, and it's a whole other story, but we can talk more about it next week. But just know, every character in a text file is essentially 2 bytes for every character. Right? So if you imagine the number, right, if we were to write the number 2 billion, I don't know, we'll just do 2 billion, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. If we just write 2 billion, that there is 10 characters long, plus a new line. And it's not huge, right? Not the worst thing in the world here. But if we go and look here at our test file, that says it's 1 kilobyte. I don't think it's actually 1 kilobyte. If we go to Properties, here we go, it's 12 bytes. It's 12 bytes? Because each character should be 2 bytes. We have 10. That should be bigger than that. Why is it only 12 bytes? Size on disk is 0. Okay, something's a little confused here, but not great. But what you can do, you can create binary type files that are not text files, where you actually store the raw data as individual bits. So we can do that. Let's make another file here. So give me just a second. I need to go copy paste that. Give me 1 second here, sorry. File IO, here we go. Here you go. So to do it this way, we're going to use a file output stream. So file output stream, like file output stream, sure. Stream equals a new file output stream, and we'll call this one test binary file. And it's not .txt. I like using .dat, but again, it's totally optional. Just any sort of extension here is fine, or nothing, again. Just know that it's a binary file, because it's just going to have raw data there. And then what you do with that, then you use a data output stream. Data output stream. Oh, I got to add my import, sorry. Add imports. And yeah, we want to do the try catch. Sure. We don't need that logger thing. That's dumb. So we're going to keep doing this inside the try. There's a new data output stream given the file output stream. So similar to when we were doing print writer and file writer, so you can get like that append mode happening. You make the file output stream and then you give it a data output stream. And data output stream lets you write individual bits. And this one, it doesn't have a print line. So data output stream, there's no print line. But what it has is a bunch of writes. You can write bytes, you can write integers, you can write booleans, you can write strings, you can write doubles, you can write floats, right? All the different types that you want to write here. So if I wanted to write an integer of 2 billion, right? Write the integer 2 billion. Make sure that's the same one, right? Is that the same 2 billion? Yeah, 2 billion, 2 billion. We can write it, and then we'll take our data output stream, and we'll close it here. Close. And we'll just print the exception. If something happens, perfectly fine. Let's run this. Oh, goodness. An exception happened. Oh, unreported exception. Oh, so it's not a file not found. It's an IO exception. There we go. Must be caught or declared. Okay. I don't know why it didn't give me that red line, but that's fine. It wouldn't even compile. Now we get our error. Or it runs, sorry. And now if we look at our folder here, let me open this one back up. Repository, show and Explorer. We have our test binary file, and we have the test file. So the test file here, again, says it's 12 bytes. I think it's a little bit more than that, but that's okay. And our test binary file here is 1 byte. Yeah, something's really funny. I wonder if I'm doing like some sort of compression on my disk here. There might be something automatic happening. So much less size because it's not storing the individual characters. Each character should be 2 bytes that don't exist or do not exist. I thought. I didn't think it could do it in one character. Maybe it did. Oh, it's yeah, because it's not using the UTF encoding. That's probably why. So it must be 1 byte per character, plus my new line. Yeah. All right, that sounds right. But the test file, that should be... That's okay. That's fine. And now what we can do, which is really cool, is you can use something called a Hex Editor. So there's this tool called VS Code, which is free. It has a little Hex Editor plugin you can get. There's all sorts of other Hex Editors you can get here. Nope, not that one, sorry. Let me pop that up on the other screen real fast. Let me close all those. Close all. Okay. And no, close that. I don't want that editor. My goodness. That's fine. Let me just go open my file. So that's in my documents, GitHub. But you can't see it. Give me just a second. 2151 summer. Exception file IO. Here's the test file. That's fine. So here's the test file.txt. And I also want to open my test binary file. And it says, oh, hey, we can't open a DAT file, don't know how to do that, but that's fine. We're going to right-click it and say I want to open... Where's my Hex Editor? Did I lose it? Goodness, it should have been there. Yeah, it was so good last time I did it, just a little bit ago. Extensions. Yeah, I have Hex Editor. There you go. So there's a little Hex Editor from Microsoft, so you can open files with Hex Editor. Open file as Hex. That's what I thought. Reopen editor with... Oh, there we go. So I'm going to reopen it with the Hex Editor instead of the text editor. And now I'll see, hey, this is the actual binary data inside the file. It looks like it's empty. That's weird. Make sure I actually got that number written. Oh, I didn't use write int. I just used write. One more time now. We'll get there, folks. Sorry, Mr. Asmiri. I don't know what that says. All right, let's try that one more time. There we go. Now I can see here. There's a bunch of values inside this file. Now, what's the size of it here? Test binary file should be 4 bytes here, because an integer is 4 bytes. There we go. That looks much better. A 4-byte integer. And then test file is larger here because we're storing it as text. But this is the actual values that are stored inside of it. So you can see individual, it's not text here, because it's trying to look at each one as a character. It doesn't work for that. Was it an installer for Python 64? Some of those looked kind of familiar. So let's see, we should be able to open this one too. Reopen editor with the Hex Editor. So this is the ASCII data here. So each one of these bytes here is a character. So 32 is the 2 in ASCII. Remember we looked at the ASCII table back in 1500? It's ASCII table. Oh, you can't see that page. How about here? Sure. So these are the Unicode values, essentially, of all of our different characters and numbers. So a 32 in... No, I'm sorry. 32 in hex. Need a bigger one. So 32 in hex here, that's the hexadecimal 32, that's the base 16, is a 2. And then 30s are the zeros, right? And then the 0D and 0A are the new line and return, carriage return. So D and A, right, a line feed and a carriage return. So each one of those characters is stored here as a byte in a text-based file. The binary file is able to store the actual values themselves here. So if we write some text then, so we could write this, write chars, write a string here then. We write that as a string. We run that again. Now, see, it's actually double in size, because now we're getting the 2-byte characters each, because each one of those should be 2 bytes here for UTF. But we don't see the new line, because we didn't add a new line there. If we added the new line character, we get our new line character as well. Okay, there's our, just a single OA, interesting. So things are ever so slightly different. And there's just the A here, which is our line feed, not the carriage return. Right, so \n is not a line feed, it's just the, or not the carriage return, it's just the line feed. It's a little bit different, but we can store stuff as binary data. Now, what's super cool with this is I can write a class here, and I'm writing a class, I don't know, we'll just call this my food. We'll have food. I'm hungry. We'll go with food. And food then will have a private string for name and a private double for cost. Right? And we'll make a constructor that takes a name and a cost. We'll add gets. What you can do with a file output stream here is you can actually write classes. You need to do a little bit of extra work to write it though. So if you want your class to be writable here, you need to say you implements this serializable interface. Serializable interface. Oh, I spelled implements wrong. I wonder why I was so confused. And yet we were going to import java.io.serializable. So if your class is serializable, what you're able to do is you're able to write it to disk in binary format. Super cool. Okay. So let's do... but instead of using a data output stream, what we need to do then, we use an object output stream. So we're going to do one more try catch here. So a file output stream, so we'll use an object output stream. Give it a new object output stream. And instead of writing characters here, what we get is we get to write... I got to add my object output stream. Object output stream. My goodness. It'd be helpful if I could type right. Ladder import. Object output stream. Dot. We get a write, and we should have a. I think that's our object output stream. Write object. We use a write object here, and we can make a. I don't know what we have, a food. Food equals new food. I had sushi, and it was what, $9.99 or something. You can write the class instance here, and then we can close it. Just give that a run. Oh goodness, what's wrong? Can't find symbol at 30. Oh, no, there's no data output stream to close. It was yelling at me, and I didn't even notice. All right, so now we're going to see there's a new file out here. So we go open up that file. Oh, no, I have the exact same file. I forgot to change the name of it here. I want this to be my test binary object. Object. Binary object. Okay. There we go. And let me open that one up. Test binary object. And we're going to open this with our Hex Editor. So we're going to open with Hex Editor. You can see there's a bunch of stuff here. But what we see, right, is, hey, it's a, here's like the exception and file IO dot food, right? That's the package name dot food, that's the class. And we see there's a name, which is a string, and we see sushi in there. So I don't see the double, but I think that's probably stored in one of these values over here. So it's able to take that and write it. And then what we can do later, we can read that. So we can have a one more try block here. We're going to try food here. And then we'll take a file input stream. File input stream equals a new file input stream. Given my test binary object.dat. And then we'll give that to an object input stream. Object input stream equals a new object input stream. Given the file input stream. Okay. And we've got to add some imports. Oh, we need our catch block. Try with the catch. Okay, we'll add our imports. Now what you can do is you can read an object. So I'm going to say, hey, my food here is equal to, and I need to cast it as a food, my object input stream dot read object. It will read the first object out of the file. I'm going to tell it it's a type of food, and then I can print out my food.get name plus food.get cost. Maybe a $sign there, right? So I'm going to be able to read it from the file. Oops, read object. What's it upset about there? Object input stream. Read object. Oh, there's also another exception, a class not found exception. Class not found exception. Shoot. Don't need that one there. So with catch blocks, you can have more than one exception type. Again, we'll get to that next week. Don't worry too much about it here. I should be able to read it, and it should read out from the file what I wrote, which is pretty cool. So if you want, you could actually go in here and edit some of these things and read other stuff, but that's all fun nonsense. So what's cool, all you have to do is make your class serializable, and as long as all of its attributes are serializable, you're fine. So we're like, if I were to go take space and make it serializable, if tool was not serializable, I'd run into trouble. But if space is serializable and tool is serializable, I'll be in pretty good shape. I can write it. Okay, so what we're going to do for the next project then, let's do project 4. Project 4, due in 2 weeks. Oh shoot, that's the midterm week. You know, should we push that out to the 20th so it's not due before the midterm? I'm not going to look at it before then anyway. Let's do that. So we're going to continue working on project 3, add an actual gameplay loop portion that allows you to explore your island and interact with the spaces, travel to a friend's island, or add friends, travel to friends' islands, and save your game, save and load. So the save and load your game, for saving and loading, implement serializable in all your classes, then write the binary objects to a file. For loading, read the objects from the file. Okay? We'll talk more about it. We'll do some more midterm review next week, but hopefully this one won't be as bad, right? Adding that game loop is going to be a little bit tricky, but be able to move around your island. It tells you what it is. Hey, do you want to dig? Do you want to chop? Do all those things. Do you want to pick up a tool? Whatever. Be able to add friends. So you can just do random islands. You can build up your own islands if you want. Shouldn't matter one way or the other. You can't see any of that. Oh my goodness, friends, I'm sorry. There we go. I was on the wrong screen there. Right, and this is not a file submission, this is a text submission, sorry about that. Please submit the URL to your pull request, feedback pull request, along with a self-assessment using the rubric. I'll post the rubric in a little bit. Please. Okay. I'll get all that posted for you in a little bit here. I gotta make a new grade here. Project 4 and projects. Okay. That other project was worth 30 points. We'll probably do another 30 for this one here. And I'll work on that rubric for you folks, okay? So I'm thinking 10 for saving, 10 for loading, 10 for the game loop. I can do that. I'll build that right now. We'll add a rubric. So project 4, and again, you're welcome to work in pairs on this one as well. If you'd like to use mine as a starting point, that's fine too. Yeah, exclam course or class there, do not exist. So complete and missing, 0 and 10 points. We'll have the game loop. We'll have save game and load game. Okay, 10 points each for our 30 points. And this will be due the week after the midterm. So if you want to get it done early, not have to worry about it, great. If you want to get it done after, that's fine too. Let me know. We should be good to go. So again, we'll come back next week. We'll talk more about file I/O. We'll do some more examples. We'll talk more about exceptions. So some of that stuff makes sense. For now, just leave it as a try-catch block. Just catch exception, and you should be in good shape. Okay? And we go from there. All right, folks, let me commit this to GitHub. So here's some file I/O. So it's totally possible to save and load using text files, but it's a whole lot harder, right? Because again, you have to know the sizes of things. Where if you can just serialize it, you just say write it to disk, and it's done. It just writes it to disk, and it's fantastic. And binary storage is even more efficient anyway than writing stuff as text. Okay. All right, folks. Let's call it a night and get some practice in. Please read the text. The textbook is full of great examples for you folks. I'll pick up some other ones, and I'll be getting caught up here shortly. I'll post your quiz for you tonight. Let's go pester somebody else on Twitch. We'll go have some fun. See if anyone else is around. Yeah, nobody else is. You can go hang out with Rob. RWX Rob. We'll have some fun there. All right, folks. Take care. Let me know what I can do to help. I've got office hours Monday and Wednesday, 3 to 4:30 and 10 to 11. Did that raid not go? It didn't go. That's all right. Gotta run. You folks take care. Let me know what I can do for you, okay?